We will discuss flip-flop. As per the definition of a flip-flop, the basic definition is that a flip-flop is a bistable electronic circuit which has two stable states. That is important. This is a stable state, and it is just like a switches where it has on or off. And in case of a flip-flop also, it is also having a two state, 0 or 1, but these are stable, not unstable. That is why, because of its stability, and this flip-flop can be used to store binary 1-bit binary numbers. That means 1 bit it can store either 0 or 1. It will not, the state will not change until and unless action is taken as per the requirement. Now, as per the requirement, as I told you, as per the requirement, the state also should be changed because it can be used as in a memory. Therefore, we use to input. We use just one of the flip-flop we are discussing, SR flip-flop, and other flip-flops are also there. Therefore, first we discuss the SR flip-flop. There are two inputs, and that two inputs will be used to change the value of Q. That is the main, what is the bit is storing. And another, in case of a flip-flop, they use that complement of Q also. That is used in some other purpose. And if it is used as a memory, that is the main, that is the storing bits. This is the storing bits, and it can be changed from the input side. That is we are discussing about. Now there are three inputs are SR. There are two inputs, and as per this type of a flip-flops, this SR flip-flop, this type of flip-flop, you will see the truth table. If S equal to 0 and R equal to 0, then output do not change. Therefore, if you make it a 0 and 0, that key is remain to the same state what it was previously. Therefore, it will not change. Now, another scenario, if you see that S equal to 0 and R equal to 1, then that output, we can say output Q will become 0. If it was before it was 1, then it will become 0, and if it is 0, it will remain as 0. Then in the other case, 1, 0, it will become 1, and last is that 1, 1. In that case, it is not allowed. This state is not allowed in case of an SR flip-flop. Therefore, I have written here forbidden. It is illegal. Now, exactly the similar way, generally flip-flop works with a clock pulses. Therefore, not only it means that, I'll just explain. If we make, suppose, as I told in this case, as I told, if it is a S equal to 1 and R equal to 0, if the previous state was 0, it will become 1. Now, if we apply here 1, if I apply here S is equal to 1 and R equal to 0, therefore Q should become 1. If it was previously it was 0, then it should become 1. But question is that this in a practical sense, the flip-flop immediately do not change. Even the Q do not change its storing value. Even we apply to S and R, it works with the clock pulses. Therefore, this is another clock pulse is there. We have shown here another input, which is a C, and that is a clock pulse. Here there are two type of a clock pulse. It's a positive triggered, negative triggered. Here that means positive triggered means when a pulse is becoming from 0 to high, then the effect will happen. That is termed as positive triggered. Therefore, if I put 1 here, I put 0, and when the pulse arrives and it goes from 0 to 1, then only the Q will become 1. Therefore, that is the meaning actually. The clock pulses, whatever shown here, is the meaning. It will not, before that, even it is 1, even it is 0, it will not change the output. It will not change Q. Only at this moment when it is from 0 to 1 happening, and that moment only the output will change. And therefore, it is another truth table has been shown here that it is the same truth table. It is only working with the clock pulses when it is coming from 0 to 1. Then that type of things is called positive triggered. And another thing, we can straight transition diagram we can draw from this truth table only. Now you can see if that the state, this is the inside I have written 0 here. This is indicating the state. That means in the state of whose? This is the state of Q. Now after a clock pulse arrives, and if I give it a S equal to 0, you can look at the S equal to 0, R equal to 0, no change. R equal to 0, no change. Therefore, if I keep it assign S equal to 0, R equal to 0, and if the clock pulse arrives, and the positive triggered clock pulse arrives, and the output remain to be 0. Therefore, this is the symbol I have taken, that it remains to be 0. Another case, if it is a 0 1, as example 0 1. Again, it was 0 before, and it remains as 0. And therefore, this is the two cases where if this clock, as the clock pulse arrive, if the S and R been assigned in these two cases, then previous state was 0 and it remains as a 0 state. And therefore, I have shown here that R is it's a don't care actually. If S equal to 0 and R, whatever the value of R, it remains to be 0. That is the thing. Now, in this case, what happens? As S equal to 1, S equal to 1 and R equal to 0. As in this case, S equal to 1, R equal to 0. In that case, what happens? If it was previously it was in 0 state, it will go to the state 1. It will go to state 1. As you can see, S equal to 1, R equal to 0, and the output will be 1. Therefore, it will go from, if it was previously it was 0 state, it will go to the state 1. Therefore, it is indicating that. Now you come to this state, here it is previously 1 and remain as 1. What are the cases here? 0 0, no change. Another case is there 1 0. If it is 1, it will remain as 1. Therefore, S is, in this case, S is no, don't care, and if R equal to 0, this phenomena will happen. Another case, that previously it was state of 1 and it is moving to state of 0. In this case, it was in that case, what are the things? If it is a 0 1, you can see if it is a 0 1, if S equal to 0, R equal to 1, it will become 0. Therefore, it was previously it was 1. Then, if we apply the S equal to 0, R equal to 1, then it will move to the state of 0. That is the state transition diagram for SR flip-flop. We will discuss the derivation of characteristic equation for SR flip-flop. For this, first let us see prepare a excitation table for SR flip-flop. How to prepare the excitation table for SR flip-flop. Now the excitation table is just prepared from the state transition diagram. Now you can see that when in the state transition diagram, when S equal to 0 and X, that means R is don't care, S equal to 0 and X, it's remain in the state. In the previous state is Qn. Previous state we are indicating by Qn, and the next state we are indicating by Qn plus 1. Therefore, previous state is 0 and the next state also will be 0. Therefore, you can see very well. Therefore, it is in case of a 0x, this is the previous state was 0 and it remained to be 0. Therefore, that is the same thing. And if it is S equal to 1 and R equal to 0, that is S equal to 1, R equal to 0, it goes from state 0 to 1. It goes from state 0 to 1. Previous state was 0, next state will be 1. Now, in case of an x0, you can see x0, previous state was 1 and next state also 1. You can see previous state was 1, next state is 1. Now if it is 0, 1, if it is 0, 1, it is a 0, 1, the previous, you can see the previous state was 1 and it goes to 0. The previous state to 1, it goes to 0. In that way, excitation table. Now to derive the characteristic equations, we have to take that Qn as the output and remaining Qn plus 1 as output, next output, and Qn, S and R are the input. These are the functions. These are the functions, and Qn plus 1 we expressed in terms of Qn, S and R. Therefore, we want to prepare a K-map on that, and therefore Qn is the most significant, S, R we have taken. And in this truth table should be prepared a bit delicately. You can see the Qn 0, 0, 0, S equal to 0, R equal to 0. Therefore, Qn equal to 0, S equal to 0. Already I said the X indicate 0 and 1 both. Therefore, it is 0 is also included here. Therefore, this is the place. Therefore, again I repeat, S equal to 0, Qn equal to 0, S equal to 0, and R equal to 0, Qn plus 1 equal to 0. Therefore, 0 I am placing. Again, Qn equal to 0, S equal to 0, R equal to 1. Now R equal to 1, which is indicating R equal to 1. This is the indicating R equal to. This is the Qn equal to 0, S equal to 0, and R equal to 1. That block is also output is 0. In this case, second row, you can see Qn equal to 0, S equal to 1, R equal to 0. That means Qn equal to 0, and then S equal to 1. This is the S equal to 1, and R equal to 0. That is the R equal to 0, and that is the block. This is the representing this block. Therefore, in this case, the output is Qn plus 1 is 1. Therefore, we are putting 1 here. In this case also, you can see that Qn is equal to 1. That means Qn is equal to 1. S equal to 0. S equal to 0 and R equal to 1. S equal to 0, R equal to 1, representing this, and therefore it is coming to the here is the 0. Therefore, we are putting 0 here. In this way, this last block also we put it into the K-map, and then K-map simplifications. After the K-map simplifications, we'll get the expression of Qn plus 1 in this form, and that is the characteristic equation.